and she's very positive too. So next scene on the stage to reconcile those who don't really like Thales's theorem and Planck's constant, because the key player, of course, makes all of this very clear, and he brought science into France's National Assembly. Cédric Villani, mathematician, Fields Medal 2010, and Member of Parliament for the Essonne, who will tell us about positive sciences in the new quantum era, interviewed by Thierry Kenner of a magazine that explores the future.
Thank you. In 12 short minutes, we'll try and talk about things that give vertigo, and we have a specialist for that. So, Cédric, you'll be our scientist tonight, and we'll try and understand what this quantum era that's going to be ours in 2018, because I heard that apart from quantum mechanics and all that jazz, we were at the eve of a major change. We are going to change our measuring system. Yes. So a meter will no longer be a meter. No, a meter will no longer be a meter. And it was an outstanding idea to address this topic in this forum, because it's a universal topic. So first, what is the quantum era? It's a concept that dates back to the beginning of the 20th century, when we realized that matter is made of small grains, atoms, that can't be split. That was a revolution. And this adventure of physics took a lot of math to be discovered. And you need to realize that at the beginning of the 20th century, people were convinced of the fact that matter was made of atom when no one had ever seen an atom. So it's theoretical work, and some bodies placed in solution that had an erratic behavior in water, and they follow the statistics calculated by theory, the theory of atoms, that convinced the scientific world. And that was Act One of a very deep revolution in physics, which was very often challenged. Einstein did not understand it, disagree with that. Well, Einstein agreed on certain aspects, disagreed on others. He emerges as a great figure for theory. Then he's defeated on certain aspects, especially about the metaphysical interpretation of quantum mechanics, which is the other huge surprise at the beginning of the 20th century. Not only is matter made of small atoms, but everything is organized in a quantum way, with packets, with quantas. When you have an atom and you try and provide it with energy, like when you heat something, you send energy to the atom. The atom can be excited with more or less energy. Imagine something more or less hot. But then you can just have certain levels of energy, level 1, 2, and 3, and impossible to have anything in between. That was something that could not be conceived back in the days. How can you imagine something that you've always understood as continuous be discrete? So is it why you say that thanks to quantum mechanics you can be here and somewhere else at the same time? Quantum mechanics is one of the more mathematic fields ever. And quantum mechanics is expressed with formalisms in which states can combine. States are never totally located. An atom is never totally in one place. It's diffused to a certain sense. Okay, that's the way to put it. And when you make a measurement that's like a linear mathematical operation that you apply to part of the system. That's one of the field in physics, which is totally abstract, the most abstract. I see that everybody is following with us so far. And Meth Landau said the way a student reacts to quantum mechanics helps us understand if a student is going to be good or not. Yeah, but Cédric, what made the entire community all of a sudden be fascinated by that? Well, because it took us a century to understand fully all the possibilities offered by quantum mechanics and using the properties of matter at a very fine level. The first great application of atomic science was the atomic bomb. On 6 August 1945, mankind changed, and the relationship between mankind and science changed, and all of a sudden we discovered everything that can be achieved, when 30 years before it was just a theory on a blackboard, and all of a sudden it became the largest industrial project and the most powerful weapon ever developed by mankind. And then we thought that by using the progress of fundamental science, 30 years later, down the road, you have very powerful things that come up away from any private economic model. Computers use part of quantum mechanics, but no one had anticipated that before. So what we're trying to do at the moment is to work out computers that use quantum mechanics in which units would no longer be bytes, but qubits, quantum bytes, using the combination properties of the multiple states of a particle to make various calculations at the same time. And if we were capable of designing such a computer would easily crack any ciphering system based on the factoring of large numbers. So we are beyond the Moore's law. It's exponential. Well, Moore's law is already exponential, but all of a sudden it's going to be on a much bigger scale, and it will help understanding, well, the time required to factor a large number will not be based on the size of this number. Okay, so before we talk about this sharp increase, what about our meter, which is going to change? Okay, just to talk about quantum computers. At the moment, quantum computers have never done better than factorizing 21 equals 7 times 3. So it's not yet achieved the level of a school kid. Yes, but IBM is working on this. Yes, IBM and many others. So far, small systems, but the hope is to come up with large systems with many fundamental questions. And among the keywords, we hear the word quantum ciphering. And if the technology is designed, it will help have total security. You can send shared keys to two individuals who will then be able to communicate with total security, unless you bribe the scientists who worked out the keys. Now, what you are saying is that with quantum mechanics, and that was summer 2017, we're changing the very definition of measuring units. So, what's the definition of a measuring unit, of a standard? We all agreed on what a meter was. That was an achievement from French Revolution. It was also political contribution. It was part of the universalist ideal of France, the idea that we had to offer a universal measuring unit to the world, and that France was the only country that was telling the truth. Yes, absolutely. We were not to wait for the Americans before the French. And the meter was created back in the days. And back in the days, mathematicians and astronomers said, we are going to create the meter from the most universal object, and that was the Earth. And they said, we are going to measure the Earth and decide that the 40,000th part of the Earth would be the meter. There were wonderful scientists, Michelin more specifically, who worked on that. And with colleagues, they were confronted to many difficulties, wars, galloping inflation, etc. And they came back. Delambre and Michelin made a mistake in their computation. Michelin almost turned crazy and embarked on a series of expeditions that nearly cost him his life. And the mistake is still there. It's not the 41st part of the Earth. And the meter is political and economic. By making it universal, it allowed exchanging in a clear way. These were the first revolts of globalization, because it was intellectual and scientific colonization of the world, an impossibility to cheat depending on the change of measuring unit. It was the standard, absolutely. And the meter became an object that represented the size of the meter. And the major change at the moment is that instead of using objects as a standard, we take laws as reference, and quantum laws. And quantum laws tell us that certain things are quantified. And we know that if you look at cesium and you shift it from one state to another, the frequency of a photon corresponding to this energy transition is set. It's a frequency, and it helps defining time. That's how we can define what a second is. The most precise, accurate clocks in the world are using this system, and the Paris Observatory has one of these clocks. And depending on whether you place it here or there, it's going to measure that time does not go at the same pace based on Einstein's theory of relativity. And it also, so Einstein, Lorentz, Poincaré, they've shown that light propagates at a constant speed. So as you have the idea of speed given by that, an idea of time by quantum mechanics, you can define an idea of length. And this is why we redefine the meter based on the speed of light and based on the frequency of a photon. Okay, we are running a bit late, but this is hard stuff. So for us as users, our meter, don't worry, your meter is going to remain the same. The meters that you've used is still going to be valid. Is it going to be the same at all times in the day? Yeah, because the change is philosophical, theoretical, but also it reflects a real change, because it shows that now in economic challenges, in innovation challenges, these laws of fundamental physics are also there, and that quantum mechanics is a challenge for the economy. Okay, so as you said, we were scared when the meter was installed. Should we be afraid of this change in the way we will count things, because we will count them differently? What, be afraid of that? No, but indirectly it prefigures an era of extraordinary precision and accuracy, but also an era of extraordinary spying activities. We are already geo-localized, Yes, because of trigonometry. Yes, trigonometry, but other things as well. I'll explain you off stage. But this is an era in which everything will be extremely precise and optimized. And when we talk about artificial intelligence, those who fear artificial intelligence fear that it's going to optimize everything too much, that it will optimize the timetable of employees and overly do so. Can we be slightly optimistic? Because what can quantum physics can contribute apart from the fact that we'll all be watched? Well, what I think is extremely positive in all this is that there are many technological developments that will change our lives that we can't suspect yet, and that will use fundamental development in physics, which are originated in the fantasies of a couple of human brains. And in the future, this will be part of global economy. This is how scientific progress all of a sudden becomes part of our daily lives and of our economy. Is teleportation on the agenda? Not soon, not anytime soon. Well, thank you so much, Cédric Villani. Thank you all. Well, good job. It does not exist yet because we're running so late. I might have decided to work on teleportation to move you. Okay, you've seen how smart Cédric is. He's a genius in math, of course. So now let's